All right, so what we're looking at today are surface views. So surface views are kind of like the big brother to um, just subclassing a view. You can do a lot of really intricate custom rendering inside of a surface view, a lot more so than you can do in just a regular subclassed view with a canvas. And there's going to be a lot that's familiar inside of here. But there's going to be some new stuff, so I kind of want to step you through this. So we're going to, we're going to go over to my virtual device. This is going to be my surface view example. This is a very boring example. Really, right now, this is just about getting it working. Now, I could have thinned this down a little bit, but I also, I embedded my surface view, my custom view, which is going to be the surface view class. I embedded him inside of a fragment just because I think you should be making apps inside of fragments. If you want to dynamically change things around, and if you want to have the ability to bring up different pages and menus and have certain extensibility, I think using things in fragments is a good idea. So we're going to get to the surface view, but before we get there, I think it's worth a little bit of a talk of using the main activity and how we get into the fragment and how we load up that surface view. So we start with our main activity. I'm using a view pager 2 over here, and remember that the view pager 2 is really just a container that allows us to dynamically load in fragments. So this view pager 2 over here is defined using the Android X. I had to bring him in using the view pager 2 specification inside of Gradle. So I have my package owner, my package name, my package version over here. I had to include this particular line inside of the app level Gradle file, and then resync my Gradle so that view pager 2 became available. Once I was able to do that, I set the view pager 2, and if you think of this guy as a frame, this is going to be a frame that allows us to dynamically swap in fragments in and out. So initialization is pretty straightforward. I have a view pager adapter over here. He extends the fragment state adapter. Fragment state adapters are used for adapting to view pager 2s. I have this class that calls create fragment, and it creates it at a particular position. For position, irrespective of the position that's passed to this, I create a new instance of the main fragment over here, right? And I'm only allowing one fragment. So this is kind of weird. It's like think of it as like a digital picture frame that's hard coded to only have one picture inside of it, but it's a container that provides for extensibility. Again, I grabbed my view pager, I assign the adapter to the view pager, and then I set that adapter, I created an adapter, and then I assigned the adapter to the view pager over here. Really, one of the reasons that you might want to use this view pager as opposed to just putting in a fragment directly inside of your main activity is that you can't dynamically swap out fragments very easily if you have a hard-coded fragment inside of an activity. And so giving the view pager is a great mechanism that helps do that, helps provide for swapping out fragments. So let's move out of here, assuming that once we've set this content view and run these logic, we're going to be into main fragment. And the main fragment, again, this is really just boilerplate code. I have my default empty constructor. I have my custom method new instance over here, which created this new fragment and returned it. And then I inflated my fragment over here. I inflated this guy to the menu, the layout fragment main. And so if we look at fragment main, this is where I'm going to actually include my custom view over here. So the my custom view, I'm going to start closing out other things. Main fragment is no longer really relevant. My custom view is over here. He's going to have a width and a height of 200 dps. I'm going to use the constraint layout app namespace to center this guy in the middle of the screen, left, right, top, and bottom. And I'm going to have to refer to the full class path over here, making sure that I use my package name and then my class name. And that's how I'm going to embed a custom view inside of a layout. Okay, so here we go. So we are now inside of custom surface view. And again, a lot of this stuff is going to be boilerplate code as well. And notice that the custom view that it actually creates is just this sort of black hole over here, or I guess square, that is 200 by 200, and it's centered right in the middle of the screen over here. So the way this guy works is we have to make, because he extends from view ultimately, yeah, he's coming from surface view, but we have to create the default constructor. But the default constructor is going to do a little bit more over here. So we need to get this thing called the holder. We get a surface view holder, and the surface view holder is going to listen for events with respect to the surface view that it tells when it's ready to actually do stuff or not do stuff. So we're not actually going to do stuff. We're just going to get things situated over here. But I am going to define my holder to be a class level variable. So of this entire surface view over here, I've got my holder and my listener. These will come in handy later on. And then I'm going to add the callback. I'm going to take this custom class that I've made over here, right? So this guy listens to callbacks, which are, it's sort of weird to describe what the holder is actually doing for the holder view. It just kind of holds this guy. I guess you could say it holds it in place. I don't know, for lack of a better term. Maybe not the best name. Hopefully it'll be more intuitive later on. But what we can sort of see is that this guy can, this holder class is going to be responsible for handling events with respect to this surface view. So like when the surface view gets destroyed, or when the surface changes, like size because of like, rotations or something like that, and when the surface is actually ready to be created, we're going to have methods, we're going to have events that are called at that point in time. And so by assigning this surface holder class to this holder, we can act on the surface view when we're ready to. So this may seem really long-winded, and it kind of is, but the deal is that we're kind of driving the Ferrari right now when you get into surface view. This guy has a stick shift. If you drive it too fast and you're in the wrong gear, you can set your engine on fire. Like you need to sort of obey the patterns and the callback events at the appropriate times if you want to draw things properly. You can draw things very intricately and very fast, but you just need to kind of play by the right steps. So as far as timing is concerned with this app, what we're going to have over here is the constructor is going to be called. Notice the constructor is going to be called, and we're going to say end of constructor. And then at some point in the future, in the indeterminate future, when the surface holder is actually ready, when the surface is actually ready, we're going to log that, yeah, well, hey, we're ready to run this guy. So I'm going to bring up my logcat. I'm going to deploy my app over here on the side, and we're going to watch the logcat to see the custom view was created. And you can see that the holder was defined, our holder listener was defined, the callback was added, we reached the end of the constructor. And then at some point in the future, when the surface was actually created, the surface was created and ready. And so this onSurfaceCreated, or the surface created method, is where we're going to start doing our drawing. This is where we're going to want to kick off threads and do drawing and stuff like that. So this method is really going to be our friend as far as doing running is, and this the constructor is really just used for constructing here. So this is the introduction boilerplate, even though it may not seem like it. This is the boilerplate code for getting a surface view up and running.